All right, so we're going to start a new topic. We're going to start talking about force. Okay? And force is actually a fairly straightforward concept, right? When you think force, you should think push or pull. In fact, that is the definition of force. Force is a push or pull. Okay? For instance, if I come over to this object I've got hanging on this spring over here, okay, this little 100-gram mass, if I give it a pull down, okay, I exert a force, and then the spring exerts a force back, and the object starts to oscillate. Okay? So force is a push or a pull. Now, there's another thing going on here, though. If I take the mass off, the spring isn't stretched out. If I hang the mass on there, it does stretch out. Now, you guys can tell me that's gravity, but can you actually see gravity pulling down on it? No. Gravity is what's called a field force. Okay? There's nothing touching it. It acts over a distance. It's due to a field. As opposed to the force I exert. If I want to exert a force, I actually have to reach over and touch it. Okay? So a force is a push or a pull, but there's two categories, two types. Okay? And these two types are contact and field. Okay? And this is when objects touch. And this acts over a distance. Okay. And you cannot exert a field force, at least not a big enough one to change anything. Okay. So some things that are field forces, gravity is a field force. Magnetism is a field force. With magnetism goes electricity, which static electricity creates an electric field, which can exert a force on charged particles, so it's a field force. Okay. But it doesn't matter what you're dealing with. If you're dealing with a force, there's always two things involved. Okay, those are the agent and the object. Okay? Forces are exerted by an agent on an object. Okay? That's important to keep in mind because there's always going to be two things that are occurring. And if you can figure out what's causing the force to be exerted, it makes the problem easier. Okay? Over here, I hang this mass on this spring, and gravity pulls down. But the spring also pulls back up. So the agent, here's one agent, the spring. Okay? Another agent's gravity, and they're both acting on this object, the mass. Okay? So agents exert forces on objects. Okay? Together, they make up a system. Okay? A system is comprised of the object and the agents acting on it. Okay. Why is that helpful to know? Well, we're going to go ahead and we're going to draw out pictures called free body diagrams that show all the forces acting on an object. And it's a heck of a lot easier to do that if you can remember what is causing all these forces. For instance, if I were to draw a free body diagram of the forces acting on that spring, okay, what I'm going to do is I'm going to take and I'm going to draw my spring. Okay, I'm going to draw my object. I guess it's kind of more squarish looking than that. Okay. And this is the beginning of a free body diagram. Okay? Here's my object. Okay? This thing. Okay? That's what I'm worried about. That's what all the forces are acting on. My system, though, is bigger. My system includes all of this. Okay? So what is included in the system? Well, gravity pulls down. So I'm going to have this. I'm going to call this Fg, force due to gravity. Okay, so gravity is exerting this force. The agent is gravity. But there's also another force right here from the spring, and this is, I'm just going to call it Fs, or F spring, okay, force from the spring. Okay. And this is really a free body diagram. This is showing me everything that's going on. Okay? Shows me gravity, shows me the spring. Those are the only forces acting. Now, the book actually says, well, let's take this one step further and make it just a particle picture. So instead of an object and a spring, we're just going to represent the object. Here's Fs. Here's Fg. Okay? Now, you'll notice I drew the forces as arrows. The reason I draw the forces as arrows is because forces are vectors. Okay? And remember, a vector includes both magnitude and direction. All right. Remember, magnitude is the how big or the how many or the how far. Direction is just direction. Which way does the force act? Okay. The magnitude of force is measured in newtons. Okay. And when you write out a unit, you use a lowercase, but when you abbreviate it, you use an uppercase. A capital Newton, if I wrote out the name, would be referring to the person. A lowercase Newton refers to the unit. Okay? So when we're drawing free body diagrams, we're going to draw arrows to represent the forces, and we're going to make sure we label the arrows accordingly. So here's the simple rules for drawing free body diagrams. Okay. First thing, identify the object. And identify the agents exerting forces. Okay. From there, you're going to draw the forces as arrows. Originating from the object and pointing in the direction of the force. Okay. All right. So it's pretty straightforward. It really is. Okay. But a free body diagram is going to help you solve a whole bunch of problems. So it's important that you know how to draw these and you can set them up. To that end, I do want to do a couple examples. Okay. And I'm going to do examples 1 and 4 on page, I just had it, page 89 in your book. And I want you to do the rest of them. Okay. So number 1 says, draw a free body diagram of a flower pot that falls freely from a windowsill. Okay. So, okay, you can go all artsy on me and you can try to draw a flower pot and cool. You don't have to. Okay. You can represent the same thing with a dot or a block. Generally, I draw blocks. Okay. This flower pot is falling freely, so I actually know it's moving this way. That's its velocity. I know its acceleration is also that way. But I want to know what forces act on it. Well, if it's a free fall problem, we can ignore air resistance. So really, this is pretty easy. Okay. This is Fg. This is my object. The only force being applied to it is the force due to gravity. You'll notice when I label that, okay, this little subscript is actually telling me what agent is applying the force. So F sub g tells me the force of gravity is acting on this object. So I know what agent is exerting the force. Okay. Problem number 4 says a rope lifts a bucket that's moving at a constant speed. Okay. So number 4, we have a bucket. Okay. Put a handle on it and a rope. Okay. We got to identify our forces and label them. Okay. Well, gravity. Always remember gravity. Okay. Fg. There's our agent. But also, the rope is pulling up. So I'm going to call this Fr, force from the rope. Now, if I redraw this as a dot, okay, then Fr is this way, and Fg is this way. Okay. Those two forces are pulling opposite directions. One's pulling up, gravity's pulling down. Okay. That's it. We're done. That's a free body diagram. It really is as simple as that. Okay. So try the rest of them on page 89. Good luck. If you have questions, email me or come see me during homeroom.